Now, we know we're using t is equal to tan of theta on 2. So we saw before that tan of what we could have for tan of theta, okay, would be the formula we had before, 2t over 1 minus t squared. So we were able to use that. So that's already been established. So now if we want to get sine of theta and cos of theta, so remember we said before about the half angles. So because it's theta there, that would be theta on 2 and cos of theta on 2. So we are able to use the results we proved previously for sine of theta on 2 and cos of theta on 2. And if we substitute those in, they'll give us just the 1 plus t squared and 2t on top. For cos theta, we get cos squared theta on 2, sine squared theta on 2. So again, do our substitutions and then expand our brackets, collect our terms to get 1 minus t squared on 1 plus t squared. So that's one way to do this, and have those three already there. There's another way to do this as well. There's another proof, and we can look at that in terms, again, tan theta is 2t on 1 minus t squared. So again, set up our triangle with an angle of theta, 2t on 1 minus t squared. And then by Pythagoras' theorem, be able to get the hypotenuse as t squared plus 1. And then you've got the opposite on the hypotenuse is 2t over 1 plus t squared, and the adjacent on the hypotenuse is 1 minus t squared and 1 plus t squared. So there's the proof. That just takes a little bit of work with your algebra. So that's probably the hardest part, is actually finding the hypotenuse there. So there's those results. Again, you need to be able to use those or remember how to get them, but you've got to be able to remember them somehow and then use them in problems.